Good morning, sir. I'm Hemant Kumar from Triple Department. Now I'm going to tell about the topic of control measures for nuclear hazards and also case study about safety protocols established for Fukushima. Let me move into the topic. Introduction to nuclear hazards. Nuclear hazards can arise from nuclear power plants, medical facilities, and research institutions. Understanding the risks associated with nuclear materials is crucial for public safety. Effective control measures are essential to mitigate the impact of potential nuclear incidents. Types of nuclear hazards. Nuclear hazards can be classified as radiological, chemical, or biological. Each type poses unique risk to human health and the environment. Identifying these hazards is the first step in implementing effective control measures. In the picture, we can observe the types of hazards: physical hazard, economic hazard, psychological, psychosocial, biological, and chemical. Regulatory framework. Government agencies established regulations to manage nuclear safety and control hazards. International guidelines such as those from the IAEA help harmonize safety measures globally. Compliance with these regulations is essential for minimizing nuclear risk. Risk assignment, risk assessment. Conducting thorough risk assessments help identify potential nuclear hazards. Evaluating the likelihood and consequences of accidents informs control strategies. This proactive approach is vital for effective emergency preparedness. Engineering controls are physical barriers designed to certain radioactive materials like mobiles and any electronic devices which produce radio waves, etc. These include containment structures and radiation shielding mechanisms. Regular maintenance and upgrades of these systems are critical for their effectiveness. Administrative controls. Administrative controls involve policies and procedures to manage nuclear safety. Training and certification programs for personnel help ensure safe operations. Regular audits and inspections are necessary to enforce compliance with safety standards. Emergency preparedness. Emergency preparedness plans outline actions to take the event of a nuclear incident. Drills and simulations help ensure that personnel are ready to respond effectively. Community awareness and participation are crucial for effective emergency management. Personal protective equipment. Personal protective equipment is essential for safeguarding workers from radiation exposure during an incident. This includes specialized clothing, masks, and dosimeters to monitor radiation levels. Proper training on the use of PPE is necessary to maximize its protective benefits. Decontamination procedures. Decontamination procedures are critical to remove radioactive substances from affected areas. These methods include washing, vacuuming, and using chemical agents. Timely decontamination minimizes the risk of prolonged exposure to radiation. Waste management strategies. Proper management of nuclear waste is essential to prevent environmental contamination. Strategies include secure storage, recycling, and long term disposal solutions. Regulatory compliance ensures that waste management practices are safe and effective. And the next case study about safety protocols established post Fukushima, enhanced safety standards. New safety standards were developed focusing on natural disaster preparedness. Facilities were required to implement measures for extreme weather events and including tsunamis and earthquakes. Strengthening building structures and creating robust flood defenses became mandatory for nuclear plants. Technology upgrades. Many nuclear facilities incorporated advanced technology for monitoring and safety systems. Real time radiation detection systems and automated shutdown mechanisms were prioritized. The implementation of passive safety systems that function without operator intervention was encouraged. Public engagement and transparency. Following Fukushima, there was a push for greater transparency in nuclear operations. Public engagement initiatives were developed to educate communities about safety protocols and risk. Open communication channels were established to address public concerns regarding nuclear safety. And the conclusion and future directions. The Fukushima disaster prompted a global re-evaluation of nuclear safety protocols. Ongoing improvements in safety measures and technology are crucial for the industry's future. The lesson learned from this incident continue to shape nuclear policy and safety standards worldwide. Thank you, sir, for giving me this opportunity.